Thank you. So, yes, hello everybody. My name is Erik Sternerson. I think I've met most of you previously. My job is as a product owner of continuous integration at a department of Volvo Cars we can call Infotainment. So that is the department that makes the computer that attaches to the various screens that you have in the car. The so-called center stack display, where you have your Spotify and your maps, the driver information module, which is behind the steering wheel, where you see the charging capacity and speed and stuff like that, and also something called the HUD, which is a smaller display that is sort of on the windshield. I got a question from Emil a while back, who had heard that we actually do quite a lot of event-driven CI in Volvo Cars. If I wanted to come and talk a bit about it, and that sounded like fun, so here I am. So I will set up the sharing, and you can please let me know if you can see the screen.
Yes.
Good. Yes, so let's start. So what I wanted to talk about in this session was both how the event-based CI looks at Volvo Cars, what tools we have around it, and what our plans and struggles and challenges are with the solution. So it's going to be a mix of slides and talking and showing some examples as well. And feel free to interrupt at any point if you have questions. I think it might be good to take them as they arrive. But let's get started. So we will start by looking at like a high-level overview of what event-driven CI means at Volvo Cars. Then we will look at the event protocol, so the specification. Then do a bit of talking and showing of tooling and services around the event-driven CI. And finally, look a bit about the future of event-driven CI at Volvo Cars. But let's start. So the world that we live in at Volvo Cars is we have many different products, meaning car models, with multi-decade maintenance windows. So once a customer has bought a car, they expect to get software updates for that car for very many years, both for security and safety reasons, but also for feature reasons. Each car has hundreds of embedded computers. Some of them are fairly complex, like our infotainment computer and also the so-called core system computer in the car. Some of them are much easier, like braking modules and windshield wipers and stuff like that. But each component, so each of these embedded computers has somewhere between 5 and 1,000 software components. Not too many have 1,000, but some do, and quite a few have less, but still it's a lot of software components in total. And we have thousands of Git repositories, not for each component, of course, but in general. I know for our computer for infotainment, I think we have around 1,400 Git repositories, and one of those is sort of a monorepo, which is very large, but even then we still have thousands. And many of these repos are updated daily. So I think on our side, again, for the infotainment computer, we build somewhere around 200, or we could build 200 new software releases per day, but we don't have the capacity to build that much. So we build roughly 50, I think. But all in all, this means that, I mean, from a timeline perspective, we have only very recently started producing and selling cars that we can actually update the software in a nice way. But as stated in the first bullet there, once we have that customer out, or sorry, once we have that car out at customers and rolling on the roads, we will need to support that car for a very long time. So all in all, this means that there is a lot of software development going on at Volvo Cars. It used to be, when I started back in 2017, most of the software we got from suppliers, but now we have quite a lot of software in-house as well. So let's then talk about how event-driven CI works at Volvo Cars today. So we have two sources of content for our vehicles when it comes to software. One is source control. So yeah, your Garrett's, your GitLabs. Another is Carport, and I will come back and talk more about the tooling later on. This is just to get an overview. Carport is where we get deliveries from suppliers, like binary deliveries then. Then we use the content that we get, either from source code or from suppliers, to trigger activities, which we do in something called Drive. And the goal of that whole, Drive would essentially start our CI pipeline. So the goal of that is to get car binaries into something called Config Hub, which is our baseline management tool. And all of this that is going on is, of course, needs to be visualized one way or another. So for that, we have a tool called Victoria. And to tie all of this together, we have our message bus. So this is like the core of the event-driven CI. Again, I will come back to all of this and show some examples and pictures as well later on. But let's focus in on the message bus to start with, because that is what ties everything together. Before we actually start looking at the protocol, just to recap, so we have from source to delivery using event-driven CI, and if any part of the chain can be made event-driven. We have, at least that's my view, completely in-house solution. It's not shared with anyone else, and it's not based on anything else that is outside. Not all of CI in Volvo Cars is event-driven. There's plenty of Jenkins and Zool and GitLab runners and GitHub actions, etc. But all of our CI flows report events. So even though the activities and things that are reported on our message bus might not have started in an event-driven fashion by other messages, they will at least be shown there. So other actions can be taken on those events, and we can get visualization on it. So that's where we are when it comes to event-driven CI. Now let's go and talk a bit about the event protocol. So there are three categories of events. It's, from a differentiation perspective, it's way less feature-rich than the Eiffel protocol. But I will come back to how we have worked around some of those parts. But we essentially only have three categories of events. It's event relating to products. So that could be source code, it could be baselines, it could be stuff like that. Then we have activities. We have activities that produce products, or we have activities that run on products. And then we have tasks, which are like subsets or steps inside activities. And those are the only three categories that we have. Then for each category, we have three types of events. We have created, so product created, activity created, task created. And they essentially announce that now there is an object, a data object that is new, that hasn't been seen before. So say that we in our CI, we start a new activity, then we can send an activity created event to say that, okay, now this activity exists and it is in some state, which we will come back to later. Then we have updated. So this is when we want to make modifications to an object that we have already created, like for instance, setting a verdict on a task or announcing that we have changed confidence labels or confidence levels on some product. Then we send a category updated, or in that case, a product updated event or an activity updated event. And both of these are emitted by, or they can be emitted by anyone. So in CI pipelines or in tooling or in scripts, you would typically see those kind of events being sent. Then there is a third event type, which is called state. And essentially what this is that anytime the object that is being referenced. So the object that was created up here in category created, or the object that was updated using product updated, for instance, whenever that changes, a state event will be sent out. So a state event is a good source for like triggering stuff, because so if we send a product created from our CS script, then the event database will send a product state event containing exactly the same information plus whatever stuff it automatically generated, if there is anything like that. So in some sense, it's a response to the other event types. Yes.
Question. Are they emitted? I mean, could they be sent, periodically if necessary? Or I mean, is there any rules surrounding when state events are sent? Do they have? Do they always convey changes, or could it be just they resend the same information?
No, so they would always convey some sort of change. Of course, it could be like if you add something and then remove something, then the third state event. Or if you have something and then you add something and then you remove something, then the third state event would have the same content as the first one, because whatever you added was removed afterwards. But it's always sent as a result of a change. It's not periodic, it's not scheduled. It's always immediately after a change was made.
Maybe we'll get into this, but why?
So I think this is, given that we have, I can briefly highlight. So given that we have different types of events here, sometimes you don't know if the information that you're asking for will be in activity created or activity updated. Say, for instance, that you want to get notified when an activity is finished, a specific activity. There's nothing saying that the sender couldn't just send activity created when the activity is already finished. But most senders would send an activity updated to state when it was finished. So then you wouldn't know, should I listen for created or updated or both? But then the safe choice is just to listen to state and just say, okay, I'm waiting for an activity state with this identifier and the state finished. Then you know, okay, then I have caught any combination of events that would lead to this specific activity being finished. Yes, at least that's my view on why this is done. So 3 event types per category, 3 event categories. That means we have 9 events in total, and that is all that we have. So let's start by looking at the product event. So the product event represents something, and this could be a source. That would be essentially a Git commit or an SVN revision or something like that. It could be a bundle, which I guess in Eiffel this would be I barely remember, a collection, I think. But it's multiple things packaged together. It's not, we'll come back to that actually. But it typically represents some sort of manifest or something like that collects many things together. It could be blob, which is some form of binary. Could be a binary load module for the car. It could be a zip package. It could be something like that. And finally, we have baseline, which is specifically for baselines that we have in our config hub tool that I mentioned before. So that has its own event type. To identify a product or a specific version of a product, we use a namespace plus instance. Namespace is essentially free text. Sometimes it's what we call a product number, which is a horrible combination of letters and numbers. Sometimes it's something more meaningful, like maybe one of our products would be Connex, which is our main department, then DHU, which is our computer for the infotainment system, and then some part of it. So it could be like connect/dhu/ something. And then instance is a unique identifier within the namespace for this specific version. And most common, I would say, is to use a UUID for that. But it could also be a version number, it could be something else, as long as it's unique within the namespace. Then everything, at least all products and activities, must have a track. Typically, this would be what branch we are on or what release we are targeting. So it could be, yeah, we are doing some factory build of cars that we want to target, or we're doing some customer release, or we just have a development on master. And the relations from the product event to other things are two, which we will show in a picture next. One is product off. So you can have a product that consists of many internal products, so to say. So this could, for instance, be that you have a one of those bundles that I mentioned before, maybe collects sources from many different source code repositories, or you could have a blob, like a built binary that was built from sources from many different repositories. So you could have any number of products stated as product off. And second, you can state what activity created a product. So the product can know where it came from, in case you want to be able to track that. And I think we can go and look a little bit at the product spec, so to say. I hope you can you see the web browser now, or is it still stuck on the presentation? I hope you can see the browser.
The browser.
Yeah, good. So we're not going to go into super details here, but this is essentially how our product event looks like. One thing I want to mention is we don't really have the concept that Eiffel has of an identifier for an event. So it's up to each event to be unique in that sense, to not re-announce something that has already been sent. At least that's my understanding. But here, as I mentioned, we have the namespace and the instance for the product. In this case, the instance is a version number, and the namespace is one of those horrible product numbers I mentioned before. This is of type source, so it refers to something in a Git repository. And then it has a whole bunch of other information. Could be like Git commit message information, etc. Yes, metadata, when we say that, we typically mean data that we will use to visualize stuff. It's not the same as Eiffel meta. And of course, custom data we have as well, which I will come back to a little bit later. We have something we call vendor, which is vendor-specific extensions, but given that it's only us that are using it, then it maybe doesn't make so much sense, but it's some additional data about the object at least. Yes. Not so much mandatory. You have to identify the product, you have to say what branch or track it's on, and you have to say whether it's source, baseline, blob, or bundle, and I think that's all when it comes to mandatory stuff. As you can see down here, we also have the concept of confidence levels. At Volvo Cars, we typically use numbers, but not always. But comparing to Eiffel, you can see quite clearly, I guess, that we don't have the same links concept as Eiffel does, but we do have links. So we do refer to objects. We don't refer to events, but we do refer to objects created by those events. And usually they are the same then. So I would say the product ID for this event is the closest thing we are going to get to an identifier for this event. With, again, the caveat that we can send product created and product updated with exactly the same product ID, because we're not, again, not really identifying an event, we're working on an object. Yes. Yes, I think that's what I wanted to show about products. I mean, we have quite a lot of stuff that is related to visualization. I mentioned titles and stuff before. We have here, like it's part of the event to be able to say what icon should be used for this so that it looks good in the visualization. Contact information, you can give like titles and descriptions, URLs that people can click, and assign some tags and some stuff like that. Yes. So that's it for the product. Again, it can consist of smaller products, and it can be created by an activity. Then the other two event categories, they are sort of or tightly coupled, so I will present them together. First, for the activity event, it represents an action, most often on a product, but not always. We actually have 3 types of activities. One is the default type, which uses exactly one product. So this would be, for instance, running a test case on a baseline, or downloading some artifact somewhere. Then we have assembly, which is an activity that uses several products. For instance, a build activity could do that. And then we have standalone, which is an activity that uses no product, like for instance, a CI, like health check job, or rebooting some hardware test rig or something like that. One not so intuitive aspect of this is that the schema for the event changes depending on which of those types you have. So if you have default, then you can only refer to one product. If you have assembly, then suddenly product is a list, and standalone, then you cannot give a product. And there are some other differences as well. So yeah, that makes stuff a little bit challenging sometimes. Identifiers for an activity is typically a UUID. So there it is. Now, it's still not an event ID because, again, we can send created and updated for the same activity. But a UUID at least. And then we always give a name and a title as well to make it friendly for visualization. And when we refer to products, then we use their identifiers, which is the namespace and instance that we looked at before. So that's how we link to the correct product version. And we have track here as well. When it comes to relations, we can relate to products, and we can say that we were triggered by some other activity. So let's look at that. So again, an activity, at least in the default variant, it always refers to a single product using the product ID. But again, for different types of activities, it could be different rules. And then it can be triggered by, so you can point to an activity that triggered it in case it has that information. When we come to tasks then, so task is a step inside an activity, and it's also identified by a UUID plus name and title for visualization. It has 2 relations. First, what activity it belongs to, and then if it's part of some tree structure of tasks. So if we look at a simple activity that only has one task, then we just send task and activity ID, but it could be more complex than that. We could have several tasks that point to the same activity, and then they would be ordered inside the activity based on their times. So when they started and finished, etc. And then each task could have a arbitrarily nested subtree of activities to say that, a subtree of tasks to say that whatever work it is doing can be broken down. So a typical use case for that, which we will look at in a picture a bit later, is where we have a task representing a test suite. And then we have subtasks representing test modules or test groups. And then we have subtasks of that representing test cases. So that's a typical use case for that. There are some things that are common for activity and task events that I haven't mentioned yet. One is they have states. So this is probably reasonably familiar to some Eiffel events. So unknown, queued, allocated, ongoing, finished, or user aborted. And then they have a verdict. which again, unknown, passed, failed, errored, skipped, or aborted. And this is a typical thing that you would then, like maybe you create the activity when state queued and verdict unknown because it hasn't finished yet. And then at some point you may send an update saying that, okay, now the activity state is ongoing, but the verdict is still unknown. And then later you will say, send another update saying that the activity is now finished and the verdict is failed. And for each of those events that you send, you will also get the activity state event being sent out so that to reflect the current state of the object. All activities and tasks have the possibility to attach metrics, so it's a key value unit triple in case you just want to send out data connected to whatever this activity and task is doing. You can send logs, so name, URL, and type. Type would be if it's like a text log or a binary log of some sort or something like that. And you can attach tickets to an activity or task event. For instance, pointing to Jira issue IDs, which we have. I would say that is not so much used from an automated sense. It's actually one of the few things on our event bus that is added manually by users. But still, when a user goes into our visual tool, the Victoria, and adds a ticket ID, then an activity state or task state event will be sent out to notify on the message bus that a ticket has been added for this event. Yes. So that's pretty much it for the protocol. We can go and look a bit on the spec for activities and tasks, but they're pretty similar. So when it comes to activities, the stuff that is required is a type, like I mentioned before, default assembly or standalone. You need an ID. You need a name for visualization. You need to have a product. Again, this is because it's default. If I switch to assembly, it will say I need to have a list of product IDs, or if I click standalone, then it will say I don't have, or I cannot have a product ID. And then we have the track, which is sort of common. It's mandatory for activities, but I don't think it exists for tasks because they assume that the task will have the same track as the activity. It is possible in the message bus, if you use drive in a certain way, that it will also state where it was run by saying allocated to. So this would be some sort of a machine or resource somewhere. You can send out actions. So this would typically be URLs that you can, essentially it creates links that you can click, for instance, for rerunning stuff or for deleting stuff or saving stuff permanently, or etc., etc. I would say it's a little bit messy that we send these out as part of the event because they don't really belong to the event instance, I would say, or the activity instance. They more relate to the type of activity. But that's how it is. There is very little persistent information about like a category of activities or anything like that. Every activity is seen as something fresh and unique that we haven't seen before. And then we build everything else dynamically based on that. State and verdict we talked about. You can give additional information about the verdict if you want to, like for instance, log snippets or specific error codes or something like that for like fault classification. Something that exists in many objects is a contact if you want to reach out to someone who can tell you more about this activity or this product. Yeah, and I think we talked about most of that before as well. Yes, and for task, it's even simpler. The only three things that are required: you need to point to an activity, you need to give an ID for this task, and here it has to be a UUID, and you need to give a name for the task so that we have something to present. And then optionally, if it is part of a task hierarchy, then you can give a parent task ID. But otherwise, it's pretty similar to how it looks for the activity events. Pretty much the same thing. Are there any questions or more details you would like to get on the event protocol before we move on to tooling and services?
Just one question.
I'm a bit curious.
Magnus, go ahead.
All right. You have both activities and tasks.
Yes.
They can be nested. Is there any particular reason you have both kinds of entities rather than just a single type of entity?
So I think this has to do with how the system is set up internally, because activities is something you can run. So yeah, you react on some event and you go somewhere and you run something. That's typically how it works. Whereas task is more a way to break things down. I mean, realistically, it would have been very possible to do this just using activities if we allowed activities to have a tree structure as well. And I don't actually know about the design decision behind why activities were not given a tree structure. But yeah, at least that's, I mean, you always need to have an activity, then you can choose to have tasks inside it if you want to. So I guess that's not really an answer to your question, but it's all the information I have about it.
Thanks.
Emil, did you have a question as well?
The state events. What kind of information do they have?
Oh, so a state event, we can actually find one here. It has all the information about the activity object, or whatever object they refer to. And again, it's, as far as I know, we never send out state events like from CI. It's always sent out from the object database or state database. Two things you can see here, which actually forgot to mention before, is that here you can refer to a version of the object. So it's always possible to say, okay, at exactly this revision of the object, it had this state. But in the other create and update, that's more like telling the object database that the object should change. You don't tell the object database what revision the object has. It's up to the state database to decide that.
But the state event is essentially just the latest version of the event, so to say, or
Yes.
the object.
Yeah, and to be extra clear, it's not the version of the event, it's the version of whatever object is being manipulated by these events.
Thank you.
Yeah, thanks. Was there more questions or comments?
Yeah. So what framework are you using to generate this web page here?
Ooh, that I will have to get back to you on. I think it might be custom, but I will need to look into that. I guess I should have said that in the beginning. I'm not really part of the team that builds all these products. I'm more of a user, but I have been involved in it for some time, so I feel reasonably qualified to talk about it. But yeah, when it comes to exactly how this is generated, I will need to get back on that. But I think it looks quite nice.
Yeah, great. Thank you.
Thanks. More questions or comments? Okay, let's go and talk a bit about tooling. So we're going to see the same picture that we saw in the beginning with the various source control stuff, etc. But now I'm going to go into more details. So again, as I mentioned before, two sources of content, source control and suppliers. For source control in Volvo Cars, generally in CI actually in Volvo Cars, we haven't really had a strong centralization of tools and what services we use. It's been up to each CI team to decide for themselves. There have been recommendations. For instance, a lot of the teams working closer to hardware is using Garrett, and a lot of teams working closer to software, like building apps and stuff for other computers. They are on GitLab. And then we have some special cases, especially the ones working with cloud products, are typically on GitHub. But now there is starting to to arrive, like more strong, not just recommendations, but actually requirements to move stuff over to Garrett, for instance. But it's been a bit of a wild west when it comes to CI and Volvo Cars, and I will come back to the consequences of that later. Some instances of Garrett and GitLab and GitHub are configured to send events for all changes, but not all of them. The one we use, for instance, because we are building products based on Android, and Android has a very large amount of repositories. We have, as I mentioned before, I think, we have 1,400 repositories that we fetch when we build. And we were told that if we connected Garrett to the message bus so that it would send events for everything that happens in that Garrett, that message bus would not be happy. So we have to be more picky about what we send. We essentially only send events for stuff that triggers pipelines or builds. Carport is an in-house solution for receiving deliveries from suppliers, except in cases where those suppliers deliver source code, because then typically they would go directly to some Garrett instance or GitLab or GitHub to deliver their source code. What Carport is, I would say, is it's a somewhat thin wrapper around the message bus and Artifactory. So it receives binaries, uploads them to the correct place in Artifactory, and then sends messages on the message bus to announce that those binaries exist. I think it also does some like virus scanning and sanity checks and stuff like that on the binaries themselves. So these two sources send events, and events are picked up by Drive. And Drive is our orchestration thing. So it takes action on events, and it does that using triggers and chains, which I will go into a little bit. A trigger is the first thing, and it's essentially filter criteria for events. So a set of rules saying, like, if an event is found that looks like this, then do something. And the somethings can either be calling a chain, which we will get back to in a minute, or making an HTTP request, for instance, to start a Jenkins job. So let's go and look a little bit on the triggers. So this is an example of a trigger. Here is the filter criteria. So it uses, I think this is MongoDB syntax, if I'm not mistaken, because I think the state database is MongoDB. And here we see, which is quite typical then, that we only look for state events. That way we don't have to worry about whether it was a product created event or a product updated event, because we know that product state will be echoed for both of those. And then we say what exact product we are interested in and what track it should be on. So whether it's on like a release branch or a master branch or something like that. And then we can have some more advanced criteria, but this is all, I think, in MongoDB syntax. So I would say that we're not really filtering on the events. We're filtering on what the event looks like in MongoDB. Then action, I mentioned we can have an HTTP action or a chain action. We can look at the HTTP first. So we say, okay, we're going to call this Jenkins server, and we are going to fetch some information from the message. We're going to fetch the URL and the instance value of the product ID. And then we will send that to Jenkins. And then it will do something interesting with that. And these chain files are typically stored as YAML files in some repository, and we connect that repository to Drive to say that, okay, you should scan this repository for chain files so that you know, for trigger files. Yes. Yeah, so this is how we take actions based on events. But then we have the chains then, which is one type of action we can take. And chains connect to what I believe is a completely in-house built activity orchestration solution. It should say SSH, but it basically works that you make a machine available to the chains or to drive, so it can SSH into it and run bash commands or Python commands that you want it to run. We can go and look at chains a bit as well. So you give it some list of activities. Each activity has some requirements, like what it needs to run, some description, and then it has actions. And in this case, yeah, just calling a bash script. You can have post actions and stuff like that as well. I have never used this part of the system, so I don't want to say or claim to know too much about it. I've used triggers extensively, but not chains, because we have always been using Jenkins on the departments I've been part of. But this was a solution for triggering activities or running activities based on events. Yes. Next one, Config Hub. There isn't that much to say about that for this session. It's a massive database of product binaries and confidence levels, so that when we want to get a set of binaries for a specific car for a specific market, we can go to Config Hub and say, please give me whatever the latest one is for this car for this market that has sufficient confidence level for us to be interested in using it. And then we will get a bunch of binaries and we can update the car using those binaries. It's not really part of the event-driven CI. It was built before we started doing event-driven CI. So there are a bunch of tools that, like, when they put data in Config Hub, they also send a message. But Config Hub itself doesn't send messages and it doesn't receive any messages either. So it's wrapped inside an event-driven shell, you could say it. And finally, we have Victoria. Here I would like to spend a few minutes because I think there are some interesting aspects of this. So Victoria, again, is the solution for visualizing, I think it's fair to say, everything. We don't have that much information on the event bus. As I mentioned, we only really have 3 types of objects: product, activity, task. And Victoria is able to visualize all 3 of those object types in a reasonably nice way, I would say. It also visualizes only from the event bus, so it does not fetch any data from anywhere else. It only works with what is on the message bus, or perhaps more correctly, it works what's in the object database, and the object database is only updated based on what happens on the event bus. So let's look at some pictures. I'm going to have to zoom around a bit here to get it into a readable state, so I hope that is okay. This is an example of a flow as visualized in Victoria. So we start by something in a Git repository. In this case, it's a manifest file. And then we create, or we start activities on that product. So this would be, as I mentioned before, that an activity can refer back to a product. And we can also create other products based on that product. So in this case, it would be more of a baseline product that we connect back to the manifest. So the manifest here is a file, but we actually create a baseline from that manifest. And then, yeah, activities can refer back to other activities. It's possible for several activities to refer back to a single activity because the arrow goes from the sort of later activity to the previous one. And you can get verdicts on activities like pass or fail. So this provides a visual view, and this visual view, there is nothing stored anywhere for this. It's generated entirely based on the content of the message bus or the object or state database. That has benefits and drawback. A benefit is that nobody needs to mess with any visualization. You just, like, if I wanted to add a new activity that connects to this manifest, I would just add that activity and it would show up nicely here. Drawback is that it can be a little bit random every time you look at it, like in what order things appear. It depends a little bit on when messages arrived. So you don't always get that nice familiar feeling when you look at the results for something. It can track dependencies. So as I mentioned, products can be, or a product can be built of many smaller products. So in this case, we have a manifest that includes the entire car. And then we have a long list of dependencies here. And each of those dependencies, if I click that, I would get a new view up here that showed like, okay, what has been done for that activity or that product. We have some stuff on the left-hand side here, mainly related to metadata. But one thing I want to highlight, we will come back to that a little bit as well, is tickets. But that will be more interesting, I think, when we look at test results. One thing we can always do in Victoria as well, which is surprisingly helpful when we, as CI developers, is we have this debug tab over here. I have a picture of that as well. This debug tab will show every event that contributed to this object or was sent for this object. So here you will get a mix of like product created event, product state events, product updated events, and more product state events. But it shows exactly what the source of this information here is. And I think especially there are some things that are not yet visualized because we haven't built support for visualizing it, but you can still find information about it in the raw event. So yeah, you can do some filtering if you're interested in some specific value. But yeah, this helps quite a bit when it comes to understanding how a certain activity or product came to be and finding more information about it. Yes. Finally, I wanted to show a little bit of information about a test run. So here I just clicked a different part of the flow, one that I happen to know contains a bunch of test cases. And then we see this task tree. So 710 is it's a task basically, and it happens to be the version number or run of this activity. And then you have this tree view then, nested tree view of stuff. And it will like aggregate information upwards. So here we have 13 activities that were skipped, 103 that were successful, and 3 that failed. And then we could dig down here. And I think I could filter as well, like only showing failing ones and stuff like that. Then on the right-hand side, here we looked before about like having links to actions. So if you wanted to say abort something that is ongoing or rerun something, then you could connect that to actions here. You can get a history. So this would say for activities or tasks that have the same name but different instances, you can get a history of like when did they last succeed, when did they last fail. And you can get logs, which I think is mainly links to logs. But here then you have the possibility to add tickets. This is, I think, either the only instance of where we do stuff manually or one of the few instances where we do stuff manually, is that it is possible, like when you're analyzing a result, say that you're looking at this update system on a test, and you realize that, oh, this is actually a new error, we haven't seen that before. Then you can add a ticket to that by going into Jira, writing a fault report, and then pasting the ID of that fault report here. It works because we only have one Jira instance. And then you will get a notice or a link over here for like all the fault reports that connect to this activity. And it's also the case that say that you attach a ticket to a specific test case. The next time a verdict is reported for the same test case, which we check by looking at the task name and what activity it is part of, then the ticket will still appear here. So we don't assume that the ticket is solved just because we get a new event or a new run of that test case. That I think is one of the few things that actually persist across multiple reports of the same task run, for instance, if the previous run of the exact same task had a ticket, then the next one will have that as well. And then it would be up to manually remove it if it's not relevant anymore.
Even if the activity passes then?
Sorry, come again?
Is that even if the test case would pass the next time, it will still be added to the same ticket?
Yes, I believe so. So we don't want, for instance, flaky test cases to lose their tickets just because they happen to pass this time.
Yeah. Another
Yes.
question, would it be possible to show what the history looks like?
It would, but then I will need to do some work in the background. I can do that. I need to start a remote desktop, but I can have that going on in the background while we look at other stuff. Yes. Sorry.
Now you're sharing that desktop.
Good. This is where I wanted to be. So you can see another web browser now, I hope.
Yep.
Good. So let's go here and look. Yeah, so now I'm navigating around a bit. Let's take this one. That's what we had before. We can do one of the failing ones. I will zoom in a bit in a second. And let's look at the history. Oops. Wow. Sorry. It doesn't scroll the way I thought. I hope that is reasonably okay. Yeah, so here we get history actually for the activity then. And it runs in like different tracks. And you can get verdicts here if something errored or failed. If something failed or was aborted, or if it was successful. And then you get history information like this. It's not perfect, I would say. For instance, once you start expanding stuff in here, you basically get like a full tree of everything, which might be a bit annoying. But yeah, it's something that we're working on improving. You can at least get like a basic trend of how this looks. Yes, other questions for Victoria while we are looking at the live stuff instead of the pre-pictured ones? Any like more questions or things you would like to look at?
Might not be direct towards Victoria, but did you say what the message bus is? That what it is? Is it like RevMQ or?
Good question. I will come to that in a second. Did we have other questions on Victoria before I move to those parts?
Yeah, I was curious how you correlate these builds in the history here. So that would be same namespace and instance, or is it? Yeah, it got to be namespace instance, and then something else, or you does it only go? Oh yeah, you have the activity ID. Those actually had IDs.
Yes, so I think it's. I don't know the exact implementation, but it's some clever combination of name, because activity ID, it changes every time you run the ID. It's actually an activity run ID.
Yeah.
So here it's some combination of its name and its context. Like, where have we seen this before? Can we find an activity with the same name that is testing the same product, for instance, or that is triggered by an activity with the same name? I shouldn't speculate too much about how this works, but it's more clever than just using the ID. We can actually look at, let's say, this one to see if we can find something that could be used for identifying the specific run. So I think it would actually be the name. I think the name. So this is not what we see. Oh, this is not super smart. It says pre-merge critical up here, but here it says something that looks more like an ID. And pre-merge critical we will find somewhere down here in something called title. So I think it actually uses the name here, the name value, to determine if something is another run of the same activity.
And the links between the nodes in this graph, they come from the events though, right?
Yes. So
Parent.
let's see if I can zoom in a bit here. So we have a link, for instance, the pre-merge critical will state that it was triggered by software preparation. So somewhere in the debug here, we should be able to find a triggered by, there we go. And that will then be an activity ID, and it will be the activity of that one. And if we look at that one, it will have that activity ID that we were looking for, not that one, this one. And it will say that I am an activity that runs on a product. So therefore, it will refer the namespace and instance ID of the product, which is what we will find over here. So that's sort of how we link things together. In this case, for instance, the instance ID here, you may recognize it, is a Garrett change ID, which is also unique, but it's not a UUID. So it's perfectly fine to have that as well.
It's not actually unique, but yeah. Might be sufficiently unique in your case.
Yes, sorry, I should say it's unique within a repository, I think.
No.
Not even that?
No, repository and branch and change ID is necessary.
Okay.
Unique, but
then that might be something that we should investigate. Okay, but back to here then. Yes, so Matthias was asking about message bus. So it's RabbitMQ in the base. I think it's quite a good deployment of RabbitMQ. I'm not super involved in the details, but it's usually up and running, and it seems to handle load quite well. And then we have the state database that I mentioned before. So a MongoDB instance, I believe, that just keeps track of all objects that have been either created or updated by events on the message bus, and also then sends state events when those objects are changed. There are some Python libraries and CLIs connected to this as well, that is delivered by the same team that builds the whole solution. And that's generally it for the message bus, but as I mentioned, it's on the rather high load, both the RabbitMQ instance, but perhaps more the state database. So it's not uncommon, unfortunately, that everything runs a bit slow when there are a lot of people who want to look at data or send updates at the same time. Yes. But yeah, this is how we connect everything together. We have some dashed arrows over here just to say that ConfigHub isn't really part of the event-driven ecosystem, but it does wrap, or there are wrappers for it that make it send events. So I wanted to wrap up by talking a little bit about conclusions and plans. So the main thing I think that is interesting for this forum to think about, or for us to reflect on in this forum, is, was it the right choice to design a custom solution? And if the question is, was it the right choice for Volvo Cars, then my view would be maybe it was the right choice. Some benefits that we have seen from using the custom solution is that it was quite easy to onboard siloed CI teams. I mentioned before that there hasn't really been a strong push in Volvo Cars to have everyone do CI the same way. So that meant that when they wanted to have various CI teams pushing data to the event bus and considering going to like Drive or those event triggered flows as well, everyone needed to do some custom amount of work to get there. And since the messaging protocol is very simple, and we had teams that were like building custom solutions, it made it quite easy to onboard. If we had tried to go to something like Eiffel or CD events when everything was so scattered, it might have been more difficult. Because it has a slightly higher threshold to get into, in my view. And since we had our own custom solution, it also made it reasonably easy to evolve. So as I might have shown before, we'll switch over here. we are actually on the third major revision of our event protocol. 2 and 3 are quite similar, but not entirely, and 1 and 2 are very different. So it made it easy to evolve. But there were some drawbacks as well, some quite severe ones. We had nobody to collaborate with. A lot of the initial designers of our event-based solution came from Ericsson, specifically from, I think, WCDMA baseband. And so we got some really skilled architects, but there wasn't really much to collaborate on, and there was nothing that worked out of the box. So a lot of custom work had to be done. So I think we had 2 or 3 teams working for several years just to get this set up.
When did you start working with this?
I think it was around 2019, I would guess. But back then there was nothing like Victoria, and there wasn't really Drive either. I think it was mostly event protocol and the triggers part, if I remember correctly. We have had to evolve in a non-backwards compatible way. As I mentioned, we're on the third major revision, and doing things in a non-backwards compatible way is really tricky, especially when we have, again, siloed CI teams. Everyone needs to do something, and everyone needs to be done at the same point and get their stuff up and running again. So it's not particularly stable, I would say. And the lack of event categories also means that we use custom data or abuse custom data. I have a good example right now where suddenly we have been asked to not only state, like for a specific build of our product, what commits are part of that delivery or that build, but also what has changed since the last build that we made. And there's no event to indicate that. We cannot point to multiple revisions of the same product. So what we ended up being asked to do was to have a custom list called list of changes, and then we just dump all the commits between the last version and the current version in there. In Eiffel, it would be perfectly possible to just link to events, and whatever observer system was interested could figure that out for themselves. At least that's my view. But for us, we needed to do custom data. And if you look at events being sent from different departments, you would probably find a unique list of custom values for every department, because there is a lot of stuff they would like to express that isn't part of the protocol. Yes. But a natural, given that it was maybe the right decision to go for a custom solution, where are we going next? And we're actually at a 3-way fork. It's decisions that is being taken way above my head, but I happen to be involved in those decisions. And one option is to just keep going with our custom solution. And I think the current leaning there is probably not, for the drawbacks I mentioned before, like having no collaboration and also having to evolve the protocol ourselves because we realize things we are missing, and then we have to rebuild the protocol to support that. And the other 2 options, one is to move to CD events. There, the major question right now is, like, when is 1.0 of CD events? When can we look at CD events as more of a stable protocol? And if that is quite soon, then I think that might be an option. But if it's too far in the future, then the third option would be to move to Eiffel, because Eiffel is sort of proven in combat for a long time. We know that it works. So it's very early days for that decision, but yeah, I was sent a decision input protocol a few days ago that had these 3 options stated. So not something that is going to happen maybe even this year or that quickly, but something that we are discussing. And I think a large reason for why we don't necessarily want to stay with our custom solution is that, yeah, there's always a rotation of people within the company. Some of the initial architects of the custom solution have left. And yeah, it becomes a situation sometimes where when some of the stronger driving forces leave, then there are teams put in place just to keep the current solution up and running, but it doesn't really evolve in a good way. So yeah, there are teams migrating away from Drive, for instance, now towards just using Jenkins instead. So yeah, at least that's my gut feeling, or my observations, is that it's probably not going to stick with our custom solution. But again, it's a massive beam of and many CI teams to convince before a change can be made. That's all I had intended to share. Thank you all for listening. If you have more questions or would like me to dive into something, I'm happy to do that.
Regarding the future there, Erik, is there also an option then, as you say, some people migrate away from Drive and do Jenkins instead? Is it so that some people say that we don't need this event-driven architecture anymore? We can stay with our own or very custom solution for our team, and we don't need the full.
No, I don't think so. I can go back to that. Can I go back to that? No, I can't. If we look at Drive, it really consists of two parts. It's the triggers and the chains. So I should have clarified that. When I say move away from Drive, I actually mean move away from chains. And instead of having triggers call chains, which is the in-house solution, you would have triggers calling Jenkins jobs. So it's still very much event-driven in that sense, but it's not using our own in-house activity orchestration. It's using Jenkins instead. And this, like calling or having the triggers running Jenkins jobs, that's actually been working well for quite some time. So I haven't really seen any push or drive or initiatives to go away from event triggering. It's just going away from this in-house chains solution.
Maybe one or a few comments about the migration path there, or the three-forked future.
Yes.
So choosing between Eiffel and seed events is something that we are looking into as well in Ericsson, obviously, since we are initiators of both of them in some sense, or in many senses. But given that we already have a user base on Eiffel, the open source Eiffel, I would say that if seed events eventually come to 1.0 and becomes broadly adopted in the world and becomes natively available in many systems, there would most certainly need to be a migration path created by the Eiffel community, or maybe even by seed events community, or in collaboration, to move to seed events kind of smoothly. So if you would move to Eiffel now, I would say it shouldn't be the last resort. I mean, if it is proven later that seed events will take over from Eiffel, then it should be hopefully fairly easy to move over to seed events from Eiffel. So it wouldn't be a very bad bet just because seed events is starting to get some traction right now.
Yeah.
And the other comment about seed events when it reaches 1.0, well, I should maybe be the one who knows, and I don't know. What could I say? Hopefully this year. There is some push for that. I'm not sure how much you're following our meetings in seed events, but work is ongoing. We did a release a month ago, and then we are right now creating a patch release on top of that. And we are looking for another release, maybe even before the summer. So 0.5 it will be then, I guess. So things are moving, but maybe not as quickly as we had hoped from the beginning. And yeah, we're quite far away from 1.0 still, I think, but the definition of far is not really clear.
No, and it's, again, like Volvo Cars is not going anywhere quickly. when it comes to something as massive as changing the event protocol. So it's not a rush, I would say, for us to get CD events 1.0, but we do have to consider like when could it potentially be available. And I would say like if it's with some probability by the end of this year or early next year, maybe that is perfect for us when it comes to timing. But if it's multiple years away or we run into some other issues when we look at it, then Eiffel is proven. And as you said, if there is that there will be a smooth migration path from Eiffel to CD events, that of course makes it less of a investment, or not investment, I would say less of a box in if we move to Eiffel.
Yeah.
So that's really good input.
If you would go to either Eiffel or CD events, would you see that you would need to be or would like to be more involved in either of those protocols to maybe affect them or add things to them before you can be able to move? Or do you think that you can move with what they look like today, more or less?
I would say that the main thing that would need to be considered is this visualization tool. That's really the most powerful thing I think we have based on our current message bus protocol. So as I mentioned before, a lot of the values and fields that we have in our events are to make visualization look good. So I think it definitely the teams that are behind this tool, they would need to spend some time verifying or checking if they could provide a similar visualization just with what CD events has today, or if stuff needs to be added. If stuff needs to be added, I would guess or think that they would like to be involved in evolving the protocol as well. So yeah.
Yeah, good.
Okay,
more questions or comments?
Yeah, I'm
Yep.
curious about security aspects. So are you, it doesn't seem like you have any signing of the events. So what if someone, would it be possible for someone to post a malicious event that would trick other actors into doing bad things?
Yes. Yeah. Security
rough
really hasn't been a particularly important aspect here. I mean, here in Victoria, as just one example, I can go in and do stuff, and there's no login on this. It's just open for everybody. But the same is true for the events. That anyone can send whatever events they want. So there's nothing that would allow you to verify that a certain author sent an event. So yet it really is lacking any kind of security thinking here. It's secure because it assumes that people don't have malicious intent, and it assumes also that the message bus is not exposed to the wider public internet.
Thank you.
Another question, if you're finished, Magnus. You talked about migration there. When you migrate between two versions or a protocol, is it that everyone needs to switch over to version 3? Or do you have like parts setting 2 and parts of 3, or?
So I think usually at least the last migration was such that first all the tooling around it was updated to support both 2 and 3. And then there was an announcement saying that, okay, now everyone should try to switch to 3 as quickly as possible. But again, nothing really happens fast in Volvo Cars in that sense. And I think what they did last time was they started tracking who sent out message bus version 2 events after a while and said, you need to switch to version 3. And then when they were reasonably confident that everyone had switched, they could go into the product and remove support for message bus 2.0. But that's really heavy operations. So it comes with a lot of cost to do it that way.
But are you sending both 2 and 3 on kind of like the same instance, or how do you differentiate between the protocols?
So I think between 2 and 3, it was, even though it's not backwards compatible, it's mostly not backwards compatible in like value types and some content. So there, I think the solution was simply to just look at the event and say, does it have version 3 data or version 2 data? I don't think there is anything in the event itself, which we can look at, of course, that will say what like protocol version it meets. We would see that over here. So I think, yeah, this event could just as well be a version 2 event, but it would have slightly different content. Between version 1 and version 2, I think all the event types were renamed, so there was less risk of collision, but it has always been sent on the same bus, is my view. I don't think we've ever had like a separate bus for version 1, 2, or 3.
Last question then. Do you need to have old events to access old events? For example, if you upgrade from 2 to 3, is there any need to go back and read version 2 events? Or is there a point where you can say we don't need them?
I would say it quite quickly, given that our objects are not really that persistent. So for instance, if we go look at this, so here we have a version of a repository, but the repository itself does not have any persistence. So like as soon as we send out a new version of this repository, if we send that out in message bus 3 format, then everything after that could refer to it in message bus 3 format. So there really isn't stuff that lives for very long in this message bus. It could, of course, be repositories that change very early. But I think, again, when we went from 2 to 3, we didn't really have those problems because 2 to 3 was not that drastic. But between 1 and 2, definitely you would need to be like resending of events for old versions of repositories just to get one object in message bus 2 format, so to say.
But yeah. you started the presentation saying that you support cars in multi-decades, but apparently then you don't use the data in this database when you troubleshoot problems in 10-year-old cars.
That is correct. That is correct. So I don't think we don't see Victoria or the message bus really as a storage for long-term data. It happens to do that quite well as long as the database is up and running, but we have others, like whenever we make a release, it starts involving a whole lot of different tools that are more in place for long-term storage of data. Okay, more questions or comments?
Maybe just more of a comment on a question related to Magnus' question before when it comes to activity versus tasks. It was quite clear in the visualization that it at least makes the visualization easier to separate those two, because you have all the activities up there and you had the tasks down in the list. Something that is not really that easy to do in the Eiffel protocol, to know what to visualize on a high level and what to visualize on a more detailed level. I'm not saying it was the reason for it, but it might have been one of the.
Yeah, definitely.
It could have been a part of it.
Yeah, that would make a lot of sense. Okay, then thank you so much for having me, and it was fun to talk about our own event solution for a while.
Thanks for being here, and I hope to meet you in Gothenburg on the Eiffel Summit in September.
Yes, I will look into that. It should be possible.
Yeah, good. Okay, I guess that concludes our community meeting for today. Great to see you attending the meeting, and we'll see if we will have another one before the summer. We don't know yet. There is no formal agenda set or any specific topics we have prepared for another community meeting, so we'll see. If you have any ideas or wishes, please reach out. Yeah, I guess we close the meeting by that then. Thanks for today.
Thank you, Erik.
See you.
Thanks.
Thank you.
Bye-bye.
Bye-bye.